Hello students. Hello everyone. Okay. So now we'll see detailed examples for your CRISP search. Okay. So what is a CRISP relations? In the last session, we have seen about what is meant by CRISP search. We have seen that the element which is completely belongs to the set will be incorporated in the set. Otherwise, it will not be added in the set. Okay, now what is meant by crisp relation? So this is very much important to understand crisp relation in order to understand the fuzzy relation. Now, what is the crisp relation? Okay, directly we are going for the example. For example, I have a relationship of fruit and a color. Okay, so if you see this particular set on the screen, so what I'm thinking here, I'm describing the relation color of a fruit X and grade of the maturity. Like for example, if it is green, I'll say that it is not ripen. Okay, example telling it is not ripen. So that is a maturity of your fruit. So what is the relation now? There is a relation between the color and the maturity. So color of the fruit is defined as X. So if you see the crisp set, X equal to green, yellow, red, and maturity Y equal to verdant, half mature, and mature. So how the relationship I'll mention. Okay, so I'll say that if X equal to green, okay, what will be the Y value? Verdant. If X equal to yellow, the Y value is half mature. If X equal to red, Y equal to mature. So this can be represented in the form of the tabular form. So I'm going to the example. Yeah, now these are your X and Y values. What are our X values? Green, yellow, and red. Verdant, half mature, and mature are the Y values. If the fruit is green, I'll say that it is verdant. So I'm mentioning here 1. If the fruit is yellow, I'll mention it as half mature, that is 1. If the fruit is red, I'll mention here mature equal to 1. So how I am mapping the relation in the tabular format? So if the fruit is green, it will be verdant. If the fruit is uh, yellow, so where I kept 1, yes, 1. So if the fruit is 1, it is half mature. If the fruit is red, the color is red, it implies that it is mature. So this way I can mention the relation in the crisp set. So how I am figuring out, I'm only telling that whether it is greener or not, that is true or false, that is 0 or 1, that is yes or no. Rather than I'm not doing anything over here. So this will be the tabular format for your crisp relation. Now, if you summarize, so same thing. So what will be the 0 and 1? As I said, if the color of the fruit is green, okay, then the fruit is verdant. If the color of the fruit is yellow, then the fruit is half mature. Similarly, if the color of the fruit is red, then I'm taking the fruit is mature. So the crisp relations will only show the existence or absence of the connection. Are you getting my point? So again, I'll go back. Here the relation is existing because green is 1, so the fruit is verdant. If I take this example, okay, I'm not having any relation with this particular half mature because if it is green, I'm fixing it is verdant. So I don't have any other option and I cannot choose it also, right? And if the green value is 0 also, it is mature. It is, sorry, if it is not mature because if I mention here also 1, then I have a conflict between verdant and mature. So this will be not happened in your crisp set. So this is a conclusion where I'll write the relation between X and Y, where X is the color, Y is the maturity. Now, exactly. So what is the meaning here? All of you just see here. So green, if the fruit is green, I'm writing verdant. Okay, 1. Okay, but if the green is 0.6% of greenish also, I'm writing half mature. So this is very much important in the fuzzy relations. Okay, so what you understood, the membership value of this particular verdant in order to become verdant according to the color green is 100%. Here half mature is 0.6% and mature is only 0 value. Okay, suppose if the fruit is 0.4 yellowish, it is verdant. If it is 1, it is half mature. If it is 0.3, it is completely mature. Okay, that is not completely mature. 0.3% may accepted as mature. Clear? So the red is 0, so there is no chance of verdant. If the red is 0.5, it is half mature. If it red is 1, then I can fix that it is mature. So if you see the previous table, only we will have only 0 and 1 values in the crisp set, right? The relation, crisp relation. But coming to here, we'll have this 0, 0 0.6, 0 0.4, 0 0.5, 0 0.3, which implies that these are the membership values of that particular element for this relation. Okay, so this is the basic fuzzy relations. Now, how we are going to calculate all these values, like how we got 0 0.6, 0 0.4, 0 0.5. So this can be calculated with a function called membership function. So which we'll discuss in the further classes, no worries. Yeah. So crisp relation is defined as a Cartesian product of two universal sets. Okay. So what we have seen here. So just I'm going back to remind you. So here you have, if this particular green equal to 1, it is verdant. So I can say that if green value equal to y, it belongs to verdant. So same thing I'm mentioning in the relationship. So it is relationship is mentioned as x cross y, where x comma y, x belongs to x and y belongs to y. Now, how I am relating, mu r is the relation between x comma y. So if it is 1, x comma y belongs to r. If it is 0, x comma y are not in relation. So what is r implies here? The relationship between two sets. Okay. Now, so same thing here, 1 implies the degree of the pair is relation and 0 implies there is no relation. Done. So we have seen the matrix and we have seen the relations. Now, one more example. So what is the example here? So we have to check the relation as x is less than y. Okay. If x is less than y, then both are in relation. Otherwise, they are not in relation. If you see the example, here x value are 145. I'm writing this side. 367, that is 367. If you see the example, 1 is less than 3. Yes, 1 is less than 3. So what we are doing here, I'm writing as 1. 1 is less than 6. Yes, 1. 1 is less than 7. Yes, 1. Okay, 4 is not less than 3. I'm putting 0. 4 is less than 6. True. 1. 4 is less than 7. 1. And 5 is less than 0. No, it is 0. 5 is less than 6. True. 5 is 7. 5 is less than 7. True. So this is a simple example for you. So please practice on it. So this is one more example. So just 1 second. We will try. So what was another example here we took? Now I'm taking. So here, remember, the function is very important. I'm taking x equal to, I have 2, 3, 4. Okay. Y equal to 1, 2, 3. The relation should be r equal to x equal to y. Okay. So I'll draw the matrix over here. So what are the values here? So x should be this side, right? 2, 3, 4. And here, what are the values? 1, 2, 3. So if I draw the matrix 1, 1. So what is the condition? X equal to y. So 2 is not equal to y. So I'll put 0. 2 equal to 2, right? So I'll get 1. 2 equal to 3? No. Good. It is 0. Again here now if you come here, 3 is equal to 1. No, it is 0. 3 is 2, 0. 3 is 3, 1. If you take the last one, 4 is 1. No. 4 equal to 2, 0. 4 equal to 3, 0. So this is our, if you see here, this is our matrix. Okay. So you can try the problems like this. So please practice problems on here. So again, we'll go back to our PPT. So same example I've shown you here. So just I'm going for the slideshow. So this is example. So in the relation, what you have done here. So we have 2, 4, 6 sides. Okay. And 2, 4, 6 sides. So here, luckily all the elements are matching. So whenever you have 2 equal to 2, I'll get 1. 2 equal to 4, it is not true. 0, 2 equal to 6, it is not true. 0. So like that, we have mapped all the elements. Done. Now, what is meant by fuzzy relation? So this is a little bit different. So what was the condition over here? What was the condition we are checking over here? R equal to x equal to y. So similarly, for every fuzzy relations, so you will have the x comma y two sets. Okay. So you have x comma y belongs to the relation which are universal sets and mu of r of x comma y. So you have to calculate this membership function. Oh, sorry. is called fuzzy relations. So remember here in the crisp relation, we don't have this thing. Only you should have this condition. See, only directly you have the relation. Directly, 1 means this belongs to the relation, 0 means it does not belongs to the relation. But coming over here, we have to calculate this particular value called mu r of x comma y. So this will be calculated. That is how you are calculating this particular relation. So mu r of x comma y, that is mu r, we are calculating the membership value of this particular function. Then x comma y belongs to x cross y. So how you are going to calculate? See, if you see here mu r of x1 comma y1. So what is the relation? x1 comma y1, yn, what is the relation? So this particular relation or the membership value can be calculated using some formula. So this particular function is called membership function. So I want to stress here more because in this particular thing, you are directly taking the value, you are putting either 0 or 1 in the crisp set, but here it will not work. So what you have to do? You have to substitute these values in this particular e power minus of x minus y whole square. So that value will be your membership value. Clear? Now, x equal to 1 to 3 and y equal to 1 comma 2. Now I have to calculate for each and every pair like 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2, 3 comma 1 and 3 comma 2. So when I substitute the values, if you see here, so this is a condition. So what was the formula here? So you have to calculate it in this one. So here, if you say this is a formula, what is your membership value? E power x minus of x minus y whole square divided by x comma y. So same thing. So this, if you see here, first relation was 1 comma 1. So e power minus 1 of minus 1 whole square by, this is the relation. So like that, you have to calculate all the values. Then you will get the membership values. So if you see here, what is the relation between 1 comma 1? It is 1. So I'm getting 1. 1 comma 2, it was 0.37. And 2 comma 1, it was 0.37. 2 comma 2, it is 1. And 3 comma 1, it is 0.2, 0.02. And 3 comma 2, it was 0.37. So this way we will calculate the fuzzy set, that is membership values. Okay. So we'll see more examples in the coming sessions. No issues. So this is how we'll calculate the functions.